Okay, here we go. Let's start it off. Okay, how about we just do it as a class then? How about 7? Yes or no? Yes. Diagonals bisect each other. 8? Nope, need both pair. 9? Nope. How about 10? Yes. Opposite sides congruent. How about 11? Yes, opposite sides parallel because those are alternate interior. How about 12? No, remember you need both pair. Both pair. How about 13? Yes, one pair parallel and congruent. And how about 14? That's a big no. Okay, so looks like we're pretty confident in how to show it's a parallelogram. Can we do it in a proof now? All right, let's do this. I'll give you guys time to mark your diagram, set everything up. And I'll warn you guys ahead of time, multiple ways of completing this. Multiple ways. All right, first thing I want to point out, do you see how it's given that PQRS is a quadrilateral? That means it has one property only, it has 4 sides. Okay, when it says something's a quadrilateral, you can't apply those 5 properties we do every day. That's only for what type of quadrilateral? That's only for a parallelogram. If it says it's a quadrilateral, you cannot apply any properties. We are trying to prove it's a parallelogram, and there's multiple ways we could go here. All right, I'll go whoever I pick next, we'll go their way. And then we'll talk at the end, well, what are other ways I could have went? All right, so what do you want to tell me now about this diagram? Here we go. 10, what do you want to tell me? 1. 7. What lines are parallel then, Amy? PQ parallel to SR, and also? There you go. And I know this has been a couple units since we've done this. What type of angles are they, Amy? And they are not just alternate interior, but congruent. Because that's what makes the lines parallel, is they have to be congruent. So alternate interior angles congruent imply, remember those days? Parallel lines. And now what do we have? What is quadrilateral PQRS? We can come up with a better name for it. What can I call that quadrilateral now? It's a parallelogram, yep. So number 3, PQRS. I'm not a big fan of the symbol. Is a parallelogram. Why is it a parallelogram? Opposite sides parallel imply a parallelogram. Okay. Was anybody going to do that a different way? Because you can, other than saying the parallel lines. No? Nobody? Huh? Max? Yeah? Go ahead. Hold on. Reset. I'm just going back to the givens, everyone. I don't know the lines are parallel. Go ahead, Max. Reset. PS and PQ. How do you know that? Are those congruent angles, though? Right? So I can't use that. Right? Anybody else? Okay, here's the diff. Ready? I already have 2 pairs of congruent angles in those triangles, right? Reflexive side, QS. What do you know about the triangles? Congruent by what method? Angle side angle. And then you could say PQ congruent to SR by CPCTC. PS congruent to QR by CPCTC. Okay, so you could have done it that way and said opposite sides are congruent instead of parallel. So don't forget about proving triangles congruent. Anything else? Questions, comments before we get to this next piece? All right. What's so different about this one? Look, I gave you a parallelogram to prove a parallelogram. Beautiful. Just like I suggested yesterday, ABCD is a parallelogram. So this entire thing is a parallelogram. So any properties we know of, we can apply. And what are we trying to prove is a parallelogram? The inside quadrilateral, EBFD. Whew. We can do it. Oh, what am I given? Oh, another given too. You're welcome. AE congruent to CF. All right, we ready to do this? Remember, the outside figure is a parallelogram. Any property you want to tell me, we can apply there. But I need to get that blue one into a parallelogram. Okay, so start thinking about, can I get sides congruent? Can I get angles congruent? Can I get sides parallel? Can we do this? Can we do this? All right, anything you want to start off with? Anything at all? Here we go. No. I don't know why it always does this during this time of the day. It always goes nuts. Anybody want to add anything? Start us off anywhere? Go ahead. Hugh? DC and AB. I wonder where he's going with that one. We'll see. DC is congruent to AB. You are correct. How do you know that, Hugh? Okay. He's good. Not bad. Wonder where he's going with that. Because remember, we got to talk sides in the blue one. Will, where's he going with that? He's going to subtract. Everyone see what he's going to subtract? He's going to take DC and subtract FC and set that equal to AB minus AE. Yep. Subtraction. And then he's going to subtract, so he can say what by substitution now? What sides are equal? DF congruent to EB. I like it. I like it, kids. All right, well, you have one pair now that's congruent. So think about the other ways I can make this into a parallelogram. I could say, ready, everyone take a look. You could say these sides are congruent, however you could do that. Or you could say these congruent sides are also parallel, that's special case. So we got two options right now. We could say these sides are parallel, or we could say the other pair are congruent. We can do both. I'm just letting you know we can do both. It depends on where you want to go, though. Any thoughts on how I can either get these two sides congruent or these two sides parallel? Hello, Emily. Okay, so Emily's like, hey, if we prove these two outside triangles congruent here and here, then we could say CPCTC, the sides. Looks like a good plan, but I only have a pair of sides. Got anything else for me? Okay, so angle A congruent to angle C. Parallelogram implies what, Emily? Okay. And anybody else see any more sides or angles to get them congruent? Hi, Amy. Oh. Yep, might as well just add that in step 2 so we don't have to rewrite it again. DA and CB are congruent. Yep. And how are we doing here? Back working? Oh, great. It did land on 19, so here you go, 19. Why are the triangles congruent? Beautiful. Woo! Triangle DAE is congruent to, let's see, if I go DAE, I better go BCF. Side angle side. And now we can say, what did we want to say by CPCTC? DE congruent to FB, CPCTC, and then what do we have now? Well, I got to go 4 on here, huh? What do we have now for that blue figure? Parallelogram. So EBFD is a parallelogram, and I'm going to be looking for somebody to tell me why. Why is that? Why do we even bother checking? Why? 20, look at that. Opposite sides congruent implies a parallelogram. Great job, everybody. Great job. We're not done, though, with this one. Do you remember when we had, right up in this step, that subtraction substitution step, we had these two congruent, and that's all we had? And I said, well, you could prove those two sides congruent, which you guys ended up doing, or we could have done what? What was our other option? Instead of proving those two sides congruent, we could have proven those two sides also parallel to do the special case. Now, I didn't expect anybody to pick that way because you don't know how to prove them parallel until I show you this new theorem that you can use now. Somebody tell me something about DC and AB other than they're congruent. We know that already. DC and AB are opposite sides in a parallelogram, so they're not only congruent, but they're also, everyone's in agreement, they're also parallel. That DC is parallel to AB. We're all in agreement. Let me ask you this question, and I don't expect you to write this part down here. Let me give you these two line segments here. And let me tell you they're parallel to each other. These two are parallel. Is this part here still parallel to that one? Are those parts still parallel to each other? Do you see how I'm applying it to that diagram now? That if the whole line segments are parallel, shouldn't the parts of them also be parallel? Okay, so if you turn your paper over to the theorems, this is something you can use now whenever you want. Oh, all right, great. All right, what do we got? I got to go backwards here. Promethean manner, what else? Oh, this is huge, no homework, huh? You know, get out of some proofs. This is for period 5 only. What's it going to be?
Star. Or the clock.
I have pinwheels. Pinwheels? Okay. So Promethean manner, pinwheels. Here we go for no homework. Ready to go? Promethean man or pinwheels? I'm just thinking about how heated I'm gonna be if it's either one, and how I'm gonna calm myself down. All right, everyone ready? Pinwheels or Promethean man? Ooh, fold over. Sorry, fold over. It's not mine, you know. Here we go, going back. There's a little clock for you. Okay, here we go. Here's that theorem. If you want to use it, if the whole line segments are equal and you want to say the parts are equal, or the parts are parallel, parts of parallel lines are parallel. Okay? So if you know two line segments are parallel and you want to say the parts are parallel, that's one I use. Hold on. What if I want to go in reverse? What if you know what if I hate going back and changing, but I will. Okay. What if we knew these were parallel, but we wanted to say the longer ones are parallel instead? I wouldn't use parts anymore, right? Instead, anybody know what word I'm going to use here? Extensions. Ooh. Extensions of parallel lines are parallel. So if you're going from shorter to the longer, that's what I would use instead. Extensions. Want to get a homework problem done with me? Okay, go to number 3. And I'll give you a second, set it up. All right, let's try to prove this a parallelogram. We knew LM and MJ are congruent. What's the deal with the median again? Who has, it's only been a unit. Goes to, okay, so can you tell, if LM is a median, can you, of triangle, or LM is a median here of this triangle, can you tell me any two segments that should be equal then? KM should be congruent to MG by definition of a median. Can you guys already tell why this is a parallelogram? Okay, why? What's the reason this is a parallelogram right now? Diagonals bisect each other, but have I said they bisect each other? No, that's why I'm doing this proof with you. You cannot say it's a parallelogram yet because diagonals bisect each other. You haven't told me they bisected each other. So that is step 3, is not that it's a parallelogram, but that LJ and what's the other diagonal? KG bisect each other. You need to state that before you say it's a parallelogram. Okay, let's talk about a reason. What's a good, I don't want definition of a bisector. Just any decent, I'm pretty flexible here other than definition of a bisector. What do you got, Emma? Okay, but easy with using the word midpoint because you haven't brought up that word yet. How do I know? How do I know they bisect each other? So you're telling me because KM is congruent to MG and JM is congruent to ML. Good job. What, Mike?
Can you not say that diagonals bisect each other as the reason?
Well, we are going to, but if that's going to be your reason, you better state that they do. I can't just assume from your diagram that they do. You need to state that they actually bisect each other before using that theorem. Now we can say GJKL is a little parallelogram because diagonals bisect each other. Imply a parallelogram. And again, if you want to use that theorem, fine, but just make sure you tell me they bisect each other. All right, solid session today. Solid set. Actually, you got still have 5 minutes, so keep going with the work because we are desk moving.